Hello everyone, I am Pushpita Chanda. I'm a PhD student at IIT Delhi under IIT Delhi and University of Queensland joint program. So I'm the TA for the course FAST. So let us begin. Today's class will be less of problem solving class and more of discussion class. Class. So first, some recap. So we know what is wave, then that is the equation. Now the F is so called which is of this to be satisfied with the equation. Now the professor has already discussed in the class that he has shown that this function is satisfied. And for you to written this wave equation in terms of electric field and magnetic field. And in the last tutorial, I have also shown how we can derive this formula from Maxwell's equations. And mu epsilon is basically root over 1 by v, or we can say v is equal to root over mu epsilon, and c is equal to 1 by mu naught epsilon. Then we know that electric field can be written as a exponential. First we can write this as a cos kx minus omega t. And I have also mentioned in the last tutorial that it can be written as just a sin kx minus omega t and other various form. We can like convert this k and omega in terms of lambda and frequency and all these things. I'm sure you remember that. And after that, we can add a phase part in that. That is called initial phase. That initially is the the cos curve is like this, but the cos curve is this that at x is equal to kx minus omega t minus theta is equal to z. Kx minus omega t is equal to 0. We will have maxima. But if it is like displaced by some phase theta, this like curve will be moved. So, and also like if that cos curve is moved by pi by 2, we can get the sine curve. That is mathematical situation, we all know that. So we have the term which is spatial quantities. This wavelength. Okay. Uh, I want to ask, was it you who just called me a few minutes back? Actually, for till August, I am in Brisbane. So uh, after that, if you want to like convey some information or ask something, you can drop me a mail. I'll reply that. But it's very hard to get a good connection on my scene here. So that was the problem. Thank you. Yeah, in what time I should wait? Yeah, that's why like I waited for 5 minutes, then continued, but you said that okay, more another 5 minutes. Okay, I'll continue the session because I need to finish something. Okay, thank you. So, and another thing, the temporal quantity, which is like time period. So both thing which is time period. So that can be denoted by T or tau. So basically, what is the wavelength? That a phase, when it repeats itself, this length is wavelength. And time for time period also, this length is T or tau the time period. But when we denote lambda here, this x-axis should be in x, and when we say time period, this x-axis need to be in time. So we know that k wave vector is 2 pi by lambda, and there is two kind of frequency, angular frequency, which is omega, and another one is cyclical frequency, which is basically 2 pi by omega, no, which is basically omega by 2 pi, which is mu. We can also say it that this is basically 1 by time period. So mu can also be denoted as frequency f. So basically k is 2 pi by lambda, f is omega by 2 pi, or we can remember omega is equal to 2 pi by f into 1 by tau. Always remember the units of the electric field, magnetic field, their dimension, and the units of the wave vector frequency. What is the unit of the angular frequency? What is the unit of the cyclical frequency? All those kind of stuff, because it's very important. So another thing is called phase velocity. So it's basically the velocity at which the phase is moving. So that is lambda by tau. V is equal to lambda by tau. We can say it's lambda mu, or it can be like denoted as omega by k. So basically, all three forms will give you the phase velocity depending on what was given on question. You need to choose which formula you are gonna use. Now we get to know that E is actually an electric field, that is a vector field, and we can denote E as exponential I as minus omega t. How we got this form, why we use tilde, that has been discussed in the class. And this is electric field, that means it's in a three-dimensional, like electric field, it's a vector field, that means it has a magnitude and direction also. It can propagate in three direction, like hypothetically, but we all know that in electromagnetic wave, there is one direction for wave propagation, one direction for electric field, and one direction for magnetic field. For simplicity, we assume that wave is propagating the z-axis, electric field in either of x or y axis, and magnetic field is in another direction. But there can be a situation that E has component in x, y, z in all form. Basically, that E doesn't have a component in Z if the wave is propagating in Z. Because like the plane wave, basically plane wave is not a real wave. We know why, and the plane wave, it has basically the infinite curvature. It is flat, but a real wave is a more localized form. And then he has written like form like this. And this term basically denote a Gaussian wave. And what is omega? Omega is basically beam wedged. This is the beam wedged, and this is defined by omega. Now, I want to mention that you can also write cylindrical wave or spherical wave. How you can write this for cylindrical wave? I am just discussing some recap, and after that, I'll discuss one or two problem on irradiance, and then the basics of Newton's ring, and some problem, one problem to discuss in it, Fabiola Itala. So for cylindrical wave, there is a like we can come to the form why we write cylindrical wave like this. There is a mathematical discussion and conclusion, but basically cylindrical wave, for cylindrical wave, the wave function should be like this. R into the function should have the function of R minus Vt. Or to like get rid of any confusion, let us write as R into psi. Psi is the wave function, should be a function of R minus Vt. So basically psi should be function of R minus Vt by R. So electric field in cylindrical coordinate can be written as by R e to the power I k dot R. negative, plus or minus. This is basically a form of a cylindrical wave. For sorry, this is a form of spherical wave. Cylindrical wave, one by root r. Cylindrical coordinates basically denoted by r, theta, and z. Spherical coordinate denoted by r, theta, and phi. If we want to show, see the whole derivation, how we get to know, get to that form, that it should be 1 by r, and for cylindrical, it should be 1 by root over r cos k r plus minus vt by epsilon by root r exponential or e to the power I k dot r minus omega t. So in the last class, I already mentioned that you can write a wave function as a cos kx minus omega t or a cos k common x minus vt. They are all same. So basically the thing is 1 by r in the amplitude denote the spherical wave, and 1 by root over r in the amplitude denotes the cylindrical wave. And then is vector field. Vector field is a field where every point has a magnitude and as well as direction. So I assume that till the point you all know that the examples of some vector field. So I should not go there because there is a question about which thing like below out of these 4 options which are vector field. I hope you can answer that thing, and also like if you like have any doubt regarding vector field, let me know. I'll discuss in next one of the next classes. And then we know that the wave equation basically a linear equation. So it follows the superposition principle. Already professor has shown in his PPT that how that follows and all those things, and I don't want to do the same thing here. You can go through the PPT, and the conclusion is basically light beams can pass through each other. and in passing through, if their polarization is same and the frequency is same, they are going to interfere. And when they interfere, the result can be constructive and destructive, and we get the interference fringe. Now, after that, we have discussed what is irradiance. So there we get three kind of like situation. One is different polarization. The different colors and it could be of sleep. It's it's star E naught Y star. So if they are different, they have different polarization, we assume that one electric field is moving in X direction, another in Y direction, because we definitely don't want to assume that like that the one of the electric field is in the direction of propagation of the wave. We normally assume that the direction of propagation of wave is Z. So we can write that as I1 plus I2. I1 is half of C epsilon E naught X E naught X star. I2 is half of C epsilon E naught Y E naught Y star. Okay. Another situation is same polarization. So in the case of same polarization, the irradiance became half of C epsilon E1 E1 star plus 2 into real part of E1 dot E2 star. Basically, E2 star means compact conjugate of E2 plus E2 into E2 star. How we came to this formula, and after the formula, how we can write I1 C epsilon real part of E1 E2 star plus I2, that has been discussed in the class. And another scenario is for beam combining with delayed replica of itself. The delay is in tau. I is basically, we can do I naught plus 3 I naught cos of omega tau. Here tau is the delay. So let us discuss some problem. So these problems are almost similar to the ones asked in the assignment. So I hope that will help you. So electromagnetic waves with electric and into 5 exponential I k z minus omega t y p n and e to t 7 exponential I k z minus omega t x y. So always remember the electric field bracket z and t denotes basically this is z. Although this electric field is moving in y direction, but the wave is propagating in z direction. That's why we put kz here and here z. Along the course, you will see that the kz is basically k dot r. Only the z component survives. That's why it is written kz for this electric field. There can be electric field where every component will survive. Different scenario can happen. So for this, in here we can clearly see that it has different polarization. Field has different polarization. So I would be half of C epsilon. So this is basically E naught x dot E naught x star. So here we don't have any complex conjugate complex entity. So we don't need complex conjugate. It's basically 5 into 5 plus 7 into 7. 5 plus 49, and that would be 37 C epsilon. Question 2. Now, So here two electromagnetic waves are 5 exponential I phase at omega t y and 3 exponential I phase at omega t y. So both the electric field is moving along the same direction. So they have synchronization. So synchronization of I plus I plus I plus 2 C epsilon real part of E1 E2 star. So here there is no complex quantity, so it will become I1 plus I2 plus C epsilon E1 dot E2. So here I1 would be half of C epsilon 5 square plus half of C epsilon 3 square plus C epsilon 5 into 3. So it would be C epsilon 525 plus 9, and this would be 15 C epsilon. So 84 15 C epsilon, that is 17 C epsilon plus 15 C epsilon. Sorry. The total, it would be 32 C epsilon. I want to be so basically, when does Newton rings get formed? I want to discuss. So when a lens, convex lens, is placed on top of a plate, the air film between these things will like work um, which has like two surfaces. This thing can be seen as an air film like this. So basically, This is a convex lens. Some like this, and some goes to transmission. And this light here also transmitted, or some of it goes stays back into the lens, and because it go through the reflection, it can go like this. And but here we don't want to like discuss what's happening inside the lens, so we basically don't worry about what happens inside the lens. So here it goes like this. We are worried about this airframe. So the light is entering the airframe in this point. Here, some of it goes back into the reflection, some goes into the transmission. And again, at that point, some of got transmitted and some got reflected. So the point here is being in Q, that is G, this is N, this is called R1, R2, this is called T1, T2. So Newton's ring can be formed via reflected beam and also by transmitted beam. What does that mean? That means if we see Newton's ring from here, we will see Newton's rings, and we can also see Newton's ring from here. We will get to see the Newton rings. But is there any difference? Yes, there is difference. So you wanted to so the this we can see Newton rings where the central fringe is dark. This is we will see when we will see via reflection, and this is the Newton rings what we will see when we see in the transmission mode. Okay, where the central fringe is bright. For Newton rings in reflected light, central ring is dark, while Newton's ring in transmitted light, central ring is bright. So for reflected light, we have seen the R1 and R2 like this R3, R4, they will, this R1, R2, R3, R4, they will interfere and give us a field pattern. So the path difference between R1 and R2 is this one, QGN. Optical path difference between Q S1 R1. So here we say it S1 and this point is S2. And Q S2, or it will not be Q, it is M. M S2 R2 will be QGN, which is basically 2ND plus minus lambda D. So D is thickness of air, or we should not say air because later we will come to know that you can put oil there. So the students who have already completed bachelor's, they will find this thing some kind of boring or repetitive, because I hope I have gone through this Newton ring thing phenomena in my bachelor's, so I think uh, most of you guys have gone through in bachelor's also, but while many people from different background can undergo this course, so that's why I'm discussing this thing in detail. So the D is the thickness of the film at N. N is refractive index. So why we are adding or subtracting lambda by D? It is because that it account the phase change at the reflection at this point G, because at G the light is being reflected from a denser surface, then the surface, it is like falling on that denser surface. So the reflection is backed by a denser surface. So that's why there should be a phase change, and that phase change can be accounted by this addition or subtraction of lambda d. So this is to consider the abrupt phase change of pi due to reflection of G. So you may ask that why the phase change is when the phase change is pi, we are adding lambda by 2, not lambda or this thing. Because we know this is the light wave, right? So this thing or this thing have same phase. So after 2 pi, or phases are same, like they are at 0. So at 0 degree phases are same, and also at the 2 pi the phases are same. So this 2 pi distance are been denoted in this spatial quantity lambda. So if 2 pi phase change happen after lambda, then pi phase change happen after lambda by 2. That's the logic. So we know that this is the path difference. That path difference has to be even multiple of 2 for making a maximum. And we can say constructive interface. Or if it is odd multiple of lambda by 2, then it is making destructive interface. So you must be thinking that n is a fixed point. So how come it became one time 2nb plus minus lambda by 2, one time even multiple of lambda by 2, and one time odd multiple of lambda by 2? You need to remember that n is not a fixed point. Right? N is can be here, it can be here, it can be here, and here. So we get fringes like this, 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 and at every end, D will also slightly change. So 2nd plus minus lambda by d is equal to even multiple of lambda by 2. We can say that that will be 2n, where n can be 0, 1, 2, 1, something, something, that. So 2nd would be 2n plus 1 lambda by 2. So this is the condition for maxima or constructive interference, and the condition for minima will be 2n lambda by 2. Okay. Now we want to know what is the radius of the ring. So for that also we need to go here. Okay, I can draw another thing. I've drawn although I'm going to draw the radius point here, but basically you will note that the radius is somewhere upper and lower point. But okay, for the like simplicity or or Jayabhata's optics book or B. Ghosh optics book, you will get this picture, and I'm sure in any other optics book there will be a chapter in Newton's ring or those things. So, assuming this is uh, bright green, so this is the radius of the curvature, and this is also the radius of the curvature, and this distance is t. This is the thickness at m, we know. So this would be r minus d. So we know r square is equal to, and this radius is the radius of the nth hydrogen. So going to 0 to r square minus although I have drawn here d, actually in Newton's ring experiment, d is very, very small compared to r. So d is very, very small compared to r. So this is r square. We can write this. So d is a very, very small compared to now, and this square is very small when compared to RT. So it would be equivalent to RT. Now, using the equation for the bright fringe, we know for maxima, we know to ND has to be 2n plus 1 lambda by 2. So now we know Rn square almost equal to 2 at t. This is equation 1. This is equation 2. From both the equation 1 and 2, you get that r square is equal to 2n plus 1 in the r2n. Okay. Similarly, if we put of light range, and similarly radius for dark fringe will be Rn square is equal to 2n lambda r by 2n. Okay. Now, we want to know the difference in dimension of the here natural number is involved. So diameters will be 2n plus lambda by r by n for bright fringe and for dark fringes it would be 4n lambda r n for dark fringes. Okay. Now we get to know that the like this is the middle, then another dark fringe. So it's really are not equal. They are not equal like thickness fringes. They are of the fringes of equal film thickness, but the fringes are not equal, doesn't have equal thickness. So this is the difference in diameters of emit and m+1th order dark fringes to show you like what's the difference and how does it like affect when we want to get rid of this +1. So this is the difference of diameter of the emit and m+1th order dark fringe, and as m increases, this difference decreases because as m increases, m plus n will tends to m. Like for example, when you add 1 to 1, it will become 2, almost double of 1. And if you add 1 to 20, so it will be 21. So root 21 minus root 20 is a significant number. But if you add 1000 plus 1, root over 1001 minus root over 1000, it is significantly less. So as the m increases, the difference between them decreases. That means the rings gradually are become narrower. That was the conclusion. So the rings will be crowded after, like as we move from the center. So that's why when we do like experiment in the Newton's ring experiment, like you must have noticed that if in a team there are 3 people and the 3 people has 3 different power. Actually, in Newton's ring experiment, you need to put a cross X at one of the fringes, take the reading, and then go on to the X fringes. And somehow that's how you take the reading, and then after you completed the experiment, then you calculate all these things. So if you are working in a team and the team members have 3 different, or you are 2 members in a team and the team members have different eyesight power, they will place the crosses at different fringes. So, and at a range where the fringes are so narrower, it is very like highly probable that if you put a fringe x at 100th number, your friend might have uh, see it at 90th number, or there will be a like huge mistake on all those like calculation. So better when you are doing this optics related experiment, always take one set of data by same person. And if you want to like in the group, all one both of you or both like all three want to do the experiment, take three sets of data. By meaning sets, I mean a complete set. Not one reading is done by you and another two reading is done by another two person and you take average manually, not like that. So then only you will get to the actual result of the experiment. So basically, Newton's ring experiment is being done for to determine the refractive index of liquid in the film and also the wavelength for this kind of thing. So this is basically the difference. The influence of other black holes. So as n increases, it decreases. So the rings of rings gradually became narrow. As the radius increases. Now we want to like know what is the thinking. So if dn and dn plus 1 are the diameters of two successive right fringes. We can write that dn plus 1 cos square minus dn square is basically 4 lambda r by n. Dn plus 1 plus dn is basically we can say 2 into dn. Because two successive like fringes has almost same diameter. When we are like moving uh, the like end of the ring, then it may differ. Like if we're taking a mth ring, like first ring and fifth ring, then it will not be 2 into first ring or 2 into fifth ring, but first ring and second ring almost have same diameter. So the fringe width, this is the fringe width. You can write it as beta became two because we are taking diameter, but fringe is basically the difference of so the changes, the fringe also changes. So beta decreases as diameter increases. For the reflected right central fringe is when m is equal to 0, that is basically the dark, but for m is equal to 0, we get dark fringe in reflected wave. But it only possible when there is m is equal to 0 means the thickness then is also like d is equal to 0. D needs to be 2 n lambda 2. So for d is equal to 0, n zero. So if d not equal to 0, then this thing will not hold. So if is not doesn't have a perfect placing on the plate, we will not have the central fringe as a dark fringe. And we were like discussing the whole thing up to this point as lambda is a like one lambda is a monochromatic light. But what will happen when we will get Newton's ring? White light. So at the center for every wavelength, d is 0. So for every lambda is 0. So center Limit is dark. But after that, it will be a colored rings because there with like when d increases, lambda become fixed but m changes. So after that thing, the rings will be colored. We can also determine the of wavelength from this experiment. So how can we do that? We will press plus compression. If Dm and Dm plus P are respectively the diameters of unit and increase P means light of the flame and equal to Jn plus P whole square minus Gn square by R. So by measuring the diameters M, D, and Dn plus P, we get lambda. So in the experiment, basically we will do this thing. This is called Newton rings experiment. So another thing is that if you like move the sorry you move the train from the Z and move it upwards. So the central point will not be a dark fringe anymore. It will be bright, and some that rings will converge to the center. But it is also possible to like measure the lambda then, and but then there will be like a different kind of assumption and calculation. Let's by number by two. Uh, which will start. But if you move the distance by odd number of multiple number by two, the center will no longer be a dark interference. It can convert to bright interference. Let us understand why. The question was consider the formation of neutrons reached by a monochromatic light lambda 6.4 centimeter. Assume the point of contact is perfect. The perfect means the point of contact, the convex lens literally touch the glass plate. There is no dust, no nothing. Now slowly raise the lens body above the plate. As the lens moves slowly away from the plate, discuss the ring pattern as through the microscope. Assume the radius of the convex surface to be 100 centimeter. So basically, capital R is 100 centimeter. Okay. So this is this will the first will be at 2. That is A. Alright. And the rays of 3 will be rays of the 3 will be okay. See, it's okay. P 2 in the see, see now raise the lens by lambda by 4. By 4. Means corresponding to moved like lengths by lambda by 4 and 2 into the by 2. So is of for means it is further by 4, then that will collapse to the center and the center spot will be dark. The ring Q will be at like um, previous like position of Q. So that's how the ring will like collapse in the center. That is why if you like make the like center moving upward, the rings will collapse to the center point. But I'll like discuss advanced classical advanced things for till now. I do like only what's in here and I like that is a much it's like can like figure and understand that the fringes have like collapsing in the center because the fringe was at 80 centimeter. Then that forms a so the other process that we can I feel great. Clearly, there is nothing to get deep into it. And to like say that in the class, professor show you a similar like feature in the first period scholar that when like, people so the Italian with the different kind of movements, a Belgian he asked why is it so there is actually uh, like from this equation we can see that and it is the NP is what is possible. This is the perspective and some this is so if somebody depends on this and this depends on theta is the counted angle angle. So when you like eliminate the echelon with this extra so basically because of this reason we get equal transmittance for all the wavelength. And also there is a third factor that the source may not have equal intensity for all the wavelength. We know that like heat of red light and violet light will not be the same. So that is the reason. So that's the reason you get a bell curve. So another thing I want to discuss is that like with the FWHM. So FWHM is what we have gotten the transmitter stuff like this and this. So we have maximum. This delta lambda. So full width at half maximum. We have that inside. If times per delta so it will happen by So which is so I'll explain how this happens as like a brief of the things I'll be discussing in the next class, and also the professor will discuss something about the class. Uh, like,